Welcome to Maths Companion. In the last video, we have discussed completing square method. There was a homework. A rectangle is to be made with perimeter 100 meters and area 525 square meters. What should be the length of its sides? Given that the perimeter of the rectangle is 100 meters, perimeter of a rectangle is 2 times length plus breadth. So we can say 2 into length plus breadth equal to 100. Therefore, length plus breadth is equal to 100 by 2 or 50. Let us take the length as x meters. Then breadth is 50 minus length or 50 minus x meters. Given that the area is 525 square meters, area is length into breadth. That means x into 50 minus x equal to 525. Now let us multiply. X into 50 is 50x. X into minus x is minus x square. So this can be written as 50x minus x square equal to 525. Now look at the term containing x square. Its sign is negative. We have to make it positive because we have to make it a perfect square. And in every perfect square, the term containing x square must be a perfect square and it should be positive. In order to make this positive, we have to multiply this term by minus 1. When we multiply this term by minus 1, we have to multiply each and every term by minus 1. Let us multiply each term by minus 1. When we multiply this term by minus 1, we get x square. Let us write it at first. When we multiply this by minus 1, we get minus 50x. When we multiply this by minus 1, we get minus 525. Now this is not a perfect square. We have to add something to make it a perfect square. What shall we add? For that, let us look at the coefficient of x. It is minus 50. Let us take 50, half it, we get 25. Square it, we get 25 square. That means when we add 25 square here, it becomes a perfect square. When we add 25 square here, we have to add 25 square on the right side of the equation also. So let us add 25 square on both sides. So we can write x square minus 50x plus 25 square equal to minus 525 plus 25 square. Now this is a perfect square. Look at the first term, it is x square. The square root is x. 25 square, the square root is 25. Middle term is negative. So this is the square of x minus 25, or this is x minus 25 all square. And we know 25 square is 625. So we can write x minus 25 all square is equal to minus 525 plus 625. Minus 525 plus 625 equal to 625 minus 525 or 100. So we can write this as x minus 25 all square is equal to 100. This is the square of x minus 25 and this is the square of 100. Taking square root on both sides, we can write x minus 25 equal to 10. Taking minus 25 on the other side, we get x equal to 10 plus 25 or 35. X is 35. That means length of the rectangle is 35 meters. We have taken breadth as 50 minus x. Therefore, breadth equal to 50 minus 35 or 15 meters. Therefore, the sides of the rectangle are 35 meters and 15 meters. Now let us do the problems on page number 86. First problem. 1 added to the product of two consecutive even numbers gives 289. What are the numbers? There are two consecutive even numbers. 1 added to the product gives 289. We have to find the numbers. The difference between two consecutive even numbers is always 2. If x is the first even number, then the next even number is x plus 2. So let us take the two consecutive even numbers as x and x plus 2. Their product is x into x plus 2. 1 added to the product means x into x plus 2 plus 1. And given that the product is 289. So we can write x into x plus 2 plus 1 equal to 289. Now let us multiply. X into x is x square, x into 2 is 2x. So we can write this as x square plus 2x plus 1 equal to 289. Now we have already seen this. This is a perfect square and it is the square of x plus 1. We know x plus 1 all square is x square plus 2x plus 1. So we can write this as x plus 1 all square is equal to 289. This is the square of x plus 1 and this is the square of 17. Taking square root on both sides, we can write x plus 1 equal to 17. Taking 1 on the other side, we can write x equal to 17 minus 1 or 16. X equal to 16 means the first even number is 16. Then the next even number is 16 plus 2 or 18. Therefore, the two numbers are 16 and 18. When you find the product of 16 and 18, we get 288 plus 1 gives 289. So the answer is right. Second problem, 9 added to the product of two consecutive multiples of 6 gives 729. What are the numbers? Let us look at the multiples of 6. 6 is the first multiple, 12 is the second multiple, 18 is the third multiple. The first multiple of 6 is 6. 6 plus 6 is 12, that is the second multiple. 12 plus 6 is 18, that is the third multiple. 18 plus 6 is 24, that is the fourth multiple. That means the difference between any two consecutive multiples of 6 is always 6. So if x is a multiple of 6, then the next multiple is x plus 6. So let us take the two consecutive multiples of 6 as x and x plus 6. Their product is x into x plus 6. 9 added to the product means x into x plus 6 plus 9. And the product is 729. So we can write x into x plus 6 plus 9 equal to 729. Now let us multiply. X into x is x square, x into 6 is 6x. So this can be written as x square plus 6x plus 9 equal to 729. Now this is a perfect square. This is the square of x and this is the square of 3. And the middle term is positive. So this is the square of x plus 3. And we know x plus 3 all square is x square plus 2 into 3 into x or 6x plus 3 square or 9. So we can write this as x plus 3 all square is equal to 729. This is the square of x plus 3 and this is the square of 27. So taking square root on both sides, we can write x plus 3 equal to 27. Taking 3 on the other side, we can write x equal to 27 minus 3 or 24. X equal to 24 means the first multiple is 24. Then the next multiple is 24 plus 6 or 30. That means the two consecutive multiples of 6 are 24 and 30. When we find the product of 24 and 30, we get 720. And if you add 9 to it, we get 729. So our answer is right. Third problem. How many terms of the arithmetic sequence 5, 7, 9, etc. must be added to get 140? Let n terms must be added to get 140. To find the sum of n terms, we need first term and nth term. First term is 5, common difference is 2, and nth term is dn plus f minus d. F is 5, d is 2. Replacing the values, we get 2n plus 5 minus 2. 5 minus 2 is 3, so we can write this as 2n plus 3. That is, the nth term of the sequence is 2n plus 3. Sum of n terms of an arithmetic sequence is n by 2 into first term plus last term, given that the sum is 140. So we can write n by 2 into x1 plus xn equal to 140. First term is 5, nth term is 2n plus 3. Replacing the values, we can write n by 2 into 5 plus 2n plus 3 equal to 140. Look at the terms within this bracket. 5 plus 3 is 8. So we can write this as n by 2 into 2n plus 8 equal to 140. 2n is 2 into n. 8 is 2 into 4. So both these terms are multiples of 2. So we can take 2 outside and we can write n by 2 into 2 into n plus 4 equal to 140. Now we can cancel these two 2's. We get n into n plus 4 equal to 140. Now let us multiply. N into n is n square, n into 4 is 4n. So this can be written as n square plus 4n equal to 140. Now this is not a perfect square. We have to add something to make it a perfect square. What shall we add? Here the variable is n. So take the coefficient of n, that is 4. Half it, we get 2. Square it, we get 4. So when we add 4 here, it becomes a perfect square. If we add 4 here, we have to add 4 on the right side of the equation also. So adding 4 on both sides, we can write n square plus 4n plus 4 equal to 140 plus 4. Now this is a perfect square. This is the square of n, this is the square of 2, and the middle term is positive. So this is the square of n plus 2, and this is 144. So we can write this as n plus 2 all square is equal to 144. This is the square of n plus 2, and this is the square of 12. So taking square root on both sides, we can write n plus 2 equal to 12. Taking 2 on the other side, we can write n equal to 12 minus 2 or 10. N equal to 10. That means 10 terms must be added to get 140. Fourth question. 16 added to the sum of the first few terms of the arithmetic sequence 9, 11, 13, etc. gave 256. How many terms were added? Let us consider n terms were added. To find sum of n terms, we need first term and nth term. First term is 9 and common difference is 2. Nth term is dn plus f minus d. d is 2 and f is 9. Replacing the values, we get 2n plus 9 minus 2. 9 minus 2 is 7, so we can write this as 2n plus 7. That is, the nth term of the sequence is 2n plus 7. Sum of n terms of an arithmetic sequence is n by 2 into x1 plus xn. 16 added to the sum of n terms is n by 2 into x1 plus xn plus 16. And given that the sum is 256, so we can write n by 2 into x1 plus xn plus 16 equal to 256. x1 or the first term is 9 and nth term is 2n plus 7. Replacing the values, we can write n by 2 into 9 plus 2n plus 7 plus 16 equal to 256. To get the terms within the bracket, 9 plus 7 is 16. So we can write this as n by 2 into 2n plus 16 plus 16 equal to 256. 2n is 2 into n, 16 is 2 into 8. So both these are multiples of 2. So we can take 2 outside and we can write n by 2 into 2 plus n plus 8 plus 16 equal to 256. Now we can cancel these two 2's and we can write n into n plus 8 plus 16 equal to 256. Let us multiply. N into n is n square, n into 8 is 8n. So we can write this as n square plus 8n plus 16 equal to 256. Is it a perfect square? This is n square, this is 4 square. N into 4 is 4n. When we double it, we get 8n. So this is a perfect square. The square root of this term is n, the square root of this term is 4, and the middle term is positive. So this is the square of n plus 4. So we can write n plus 4 all square is equal to 256. This is the square of n plus 4 and this is the square of 16. Taking square root on both sides, we can write n plus 4 equal to 16. Taking 4 on the other side, we can write n equal to 16 minus 4 or 12. N equal to 12 means 12 terms were added. Now there is a homework. An isosceles triangle has to be made like this. The height should be 2 meters less than the base and the area of the triangle should be 12 square meters. What should be the length of its sides? We will discuss the remaining problems in the next video. Till then, bye.